Okay, hello everybody. Welcome to this session. This next couple of hours, I'll demonstrate you working with OpenRoads and OpenRail designer. So let's start with looking at the capabilities and salient feature of the softwares. So OpenRoad Designer Connect Edition is a successor to Bentley's industry-leading civil engineering brands InRoads, Geopack, MX, and Power Civil. This application supports all aspects of a detailed roadway design, including survey, geotechnical, drainage, subsurface utilities, corridor modeling, analysis, and quantification. So it's like a suite of multiple modules. Okay, so different disciplines work on the similar same software. They use their dedicated tools. It is a comprehensive multidiscipline 3D modeling application that advances the delivery of roadway projects from conceptual design through the construction. OpenRoad Designer provides the latest technology and tools you need to efficiently design, model, and produce project deliverables in a dynamic, interactive, and parametrically enabled environment. So in OpenRoad Designer, the object you create maintains relationship between each other. So it remembers how they are built. So they are dynamic to each other. When you change any object, the other object which is related to that will automatically maintain the relationship and changes accordingly. Like other Bentley software, it runs on MicroStation platform. So it's about the introduction of this software. Now let's see the salient features, why it is quite popular among the infrastructure industry. So it's uses one file system. Unlike the predecessor, there were multiple files for storing the different objects, like one for alignment, one for terrain, one for corridor, templates, etc. In OpenRoads Designer, everything can be stored in a single file, in a single DGN, whether it is graphics or design data, everything. But it is recommended that you create a separate file for each object, like one for alignment, one for corridor, and so on, and work in a federated way, so that if one file gets some issues, the others won't affect. But yeah, you can save, if you want, you can save everything in a single file. So it comes with workspace and work sets. So it is used to externalize the projects. So workspace and workset are a custom environment. It can be understood as a container where you can keep the project specific data. And when you select a workspace and worksets while creating a new project, it connects to that particular location, that particular container. And every time when you browse for any required resource to model your roadway, it will take you directly to that particular folder, or you say space. So it can be on your PC, on your computer, it can be on network drive, and it can be on the cloud. So it saves times. Otherwise, you can waste some time looking here and there for the correct standard setting files. So it comes with a customized workflow. When you start the OpenRoads, you will see multiple workflows already created. So workflows are basically the arrangement of tools and settings which is required for a particular kind of work. Let's say you're doing drawing work and you select a drawing workflow. It will show you all the tools which is required for the drawing and hides anything which is unnecessary. If you select the OpenRoads workflow, it will bring all the tools in front and hides everything which is not required. So this is how you can create more space while doing modeling using the customized workflow. It comes with integrated maps. So in past, like we used to use the third-party software to download the maps and integrate with our software while working. But in OpenRoad Designer, it comes with integrated map powered by Binge, Microsoft Binge. So you don't need any third-party software or tool. So it comes with predefined view setup. So you can have 8 views simultaneously in OpenRoad Designer. So, and it comes with a predefined setup, 2 views, 3 views, 4 views, like one for plan, one for 3D, and one for cross section, 2 views, one for plan and cross section. So it comes with a predefined view. So whenever you require to work in the multiple views, you just select the predefined view. So you don't need to manually open the views and do the setups, which takes much time. Then it comes with text manipulator, is very powerful tool. So if you need to modify any object you have created, you select the object and it pop-ups a text manipulator. You just edit the values and it will update other design. So this is a very powerful tool. It comes with every object. Then dynamic relationship between the objects. As I said, it maintains dynamic relationship. Let's say you created two lines which are perpendicular to each other. So when you change the location of one object, like the orientation or anything, or the position, the other line will maintain the relationship. It will remain always perpendicular to the second line. I'll show you how. So anytime the design changes, all the related, like if you change the alignment, the corridor will automatically update because the corridor is modeled on the base of the alignment. So the cross section will automatically update. Okay, so this is how the dynamic relationship saves lots of time. It comes with an integrated template tool. So template is like the typical section. So unlike in other software like Civil 3D, where we have a separate tool to create the template, you create the template and you bring it into the software. Okay, but unlike other software, it comes with the integrated tool. So you edit the template and you update, and your corridor will update automatically. So it comes with automated drawing production tools. So you don't need to do drawing production manually, which take a lots of time. So it comes with automated tools to create drawings like plan, profile, plan, and cross section. So every type of drawings you can create using the dedicated automated tools and workflows. It also comes with the integrated visualization tool. So if you need to do visualization to show the any of the stakeholder, you can do it. You don't need any third-party tool. And also it can handle a large volume of data. Okay. So this is the salient features. Now let's jump onto the software. And I'll show you how you can do roadway modeling quickly in OpenRoad Designer. Okay, so this is a starting window. This is called the backstage window of the OpenRoad software. So while creating a new file, you need to select the workspace and workset. As I said, these are the custom environment. So when you select, let's say within a training example, you have 3 worksets. So workspace is like organization. It can be a department of transportation, let's say NHIE, and workset is like a department within that organization. So they may have a different standard set for their own department. So this is basically the subcategory of workspace. Okay. So when you select a workspace, it will show you all the required subcategories or discipline or department within that category, and you can opt from it. Let's say if I can training imperial workset, hit on this new file, and then you need to select a seed file from here. So seed file is basically a template file which holds all the settings for the particular project. And when it's like a empty file, it just holds the settings. So when you select a seed file and create a DZN file, all the settings gets copied from that seed file to your DZN file. So it basically standardizes your documents. Let's say there are a team of 5 people working from 3 different offices. So if they use the same seed file, which is kept at a common environment, so okay, so they will have the same setting as their files. Okay, so it reduces the chance of setting up any wrong units or any GCS, etc. Then give this a name and save it. So now this DZN file will load all the library from that particular container, from that workspace we have selected. So it will load all the required resource. Let's see, it's loading. And once everything is loaded, it will open the file. Okay. So this is the working area. And here on the top left corner, you will see these are the workflows. So if you select a workflow, let's say I select a survey workflow, see the change on these ribbons. So when I select a workflow, it brings all the necessary tools which is required for that particular task. Right, for drawing, I need all the drawing tools in front. Okay. So while modeling, I would be needing all the design related tools here. See. So this is the workflow. Then you will see this is the predefined views. So let's say I need 3 views: plan, profile, and 3D. It will create. Two views, plan 3D, like that. So otherwise, if you don't have these predefined setup, you will end up opening these views manually and then setting up them. So it takes time. So the predefined setup saves lots of your time. So this is the advantage. So this runs on the MicroStation platform. So you will see all the tools which is available in the MicroStation. So you can use OpenRoads Designer as a MicroStation standalone tool. You can do drafting or design as well. Okay. And let's say how dynamic relationship it maintains. So I'm creating a line here. Second line, I'm creating perpendicular to this first line. Okay. So now these two lines remembers how they are created. They remembers the relationship. So let's see. When I'll change the location or orientation, the second line always maintains that perpendicular relationship with this line, like that. So these are the smart objects. And like if I use a simple go to drawing, I create a simple MicroStation graphics, a simple line. In the same way, now see, these are static elements. These are MicroStation element, and these two are OpenRoads element. So they maintain relation. They are dynamic in nature. So this is a difference. Okay, now let's come to the workflow. So workflow to do roadway modeling in OpenRoads is first you create a terrain model, you import the terrain model, then you do the geometric design, horizontal and vertical alignment, then you have a template, then you create the corridor and the drawing production, like that. So let's start with attaching a terrain model. So before that, you need to set up the GCS, geographic coordinate system. So we have this dedicated tools to set the GCS. So you can see the GCS is already set. So it comes from that seed files. In the seed file, we already set up these coordinates so that every time I need to work on that particular region, You don't need to do it again and again. So this is the benefit of using the seed file. So it will set you the GCS, it sets all the drawing settings for you. Let's say the units. So it's already set. Your survey feet, survey inches, like that. Okay. The toolbars are floating type, so you can float and set anywhere as required. Okay, so now GCS is set. Let's attach the terrain model. So this is the terrain model. Then let's attach one more file. So this file contains the PIs, the intersection point we'll be using to create our geometric design. So first we create a horizontal geometry. To do that, go to first change the workflow to OpenRoads modeling. And from this geometry ribbon, here is the horizontal alignment tools. So we'll be creating line first, line between points. Snap to the center, the circle first. Okay. So before creating any object in OpenRoads, you need to select a feature definition for that. So feature definition will control the representation of the graphics, like its color, line style, line weight, etc. Select gem baseline. Let's see. Now the color has changed when you select a proper feature definition. Otherwise, it was white in color. Second tangent, third tangent. So you're done with all the tangents. So I can toggle off the display of this file. Okay. Now let's check our integrated map. So the GCH is set. So to view the integrated map, you must set the geographic coordinate system. Only then you can see this option here. So you have three types of map here: state maps, aerial map, and hybrid map. Hybrid of both. Let's see. So this is a correct location. So you can have the hybrid map, aerial plus street map. So you can know the name of the roads. So this is the London Road. Let's toggle off the view. So our tangent is created. Now let's create curves between these tangents. So we'll use arc between element, a simple arc. Okay. Set the feature definition back to geom baseline. First element, second element, and type in the radius. Left click to accept. It says trim both, left click to accept. Then we have 1, 2. Accept, left click to accept. The third one, type in the value. So all our curves are now created. So let's say I need to change the radius of the curve from 600 feet to 700. So when you click on that object, this text manipulator appears. You see, just click on this text manipulator, type in a new value, and then okay. So all the components, all the elements of our geometric horizontal alignment is created. So I need to join them to make a complex alignment. So go to complex geometry tool here, complex by elements. Again, set the geometric uh, feature definition and give this a name. So this is London Road. Hover over the first element and verify the direction. Set this to automatic. Okay. So in the automatic mode, it will take all the connecting elements together. Again, left click to accept. So now this is a complex horizontal alignment, you can see. So even after making it complex, you can edit the alignment using the text manipulator like that. See, this should be 2100. Okay, like that. After that, we annotate our alignment to show the chain edges. So go to drawing production. Here we have the element annotation. Select, locate element, reset to complete. So right click, and here we have, this is point of beginning. So the chain edge starts from 0. Let's say we need to start our chain edge from 50 plus 00. So go to geometry tool, modify, and start station. So set the start station to 50 and locate element. Start distance 0, parameter start station 50, and see. So you can change the start station anytime. So our horizontal alignment is created. Now let's move to create our vertical profile. So before that, we need to activate this terrain model. To do that, select this, hover over, and click on this tool. It says set as active terrain model. So this is now our active terrain model. Now to create the vertical profile, select this alignment and hover over this alignment. So these tools will appear. From here, click on this tool, open profile model. And it says select or open view. So select view number 2. See. So this cyan line shows the horizontal curves. Okay, so let's create our vertical profile. So here from the vertical tool, select the profile line between points. Tie into the starting point to the ground. And again, set the feature definition. So next one, Okay, now create curve between these tangents. So go to curve, profile curve between points, between elements, parabola. So first element, second element, parameter trim extend both. Then first element, second element, like that. In the same way, if you want, you can modify the alignment. Let's say I need to change the curve then from 600 to let's say 1000. So you can adjust your profile precisely to minimize the cut and fill so that it blends with the natural ground. Okay. Once we are done with this alignment, in the same way, we need to join these elements to make complex vertical profile. So again, we have this complex. Set this to automatic. Give this a name. Can click on the first element and verify the direction. Left click to accept. And so now let's make this profile active. Select this. Click on this tool, set as active profile. Okay, so our vertical profile is done. Now let's create our corridor. To create a corridor, go to this corridor tab and click on this new corridor. So it says locate corridor baseline, your alignment. Select that. And it says locate profile or reset for active profile. So we set our profile active. So just right click, feature name, corridor name. Let's give it the name, same name. Left click to accept. Parameter template. So we have the template library. So if you hit Alt and down button, so it will take you to the library. So here you have already created a template library provided by the Bentley with the installation. You can make edits to the templates. So I have this templates, rural. So we have this simple tool and road. Take this. Left click to accept your template. And it says parameter start. Either you can snap to the start point looking at the graphics, or you just hit Alt key. So it will lock to the start station. Left click to accept. Again, it says end station. So again, you hit Alt key and it will lock to the end station. So parameter drop interval. So at what drop interval you want to drop your template to create the corridor. So let's say 25. And your corridor is created. So let's see how it looks in the 3D. So to open two views, view control, plan and 3D. See. So you can see your model in different view style. Let's say you don't want to see these edges set as the smooth. You can change the lightning. So this is a complete corridor. Okay, so if you want to look at the corridor section by section, open three views, plan, cross section and 3D. So select OK to create a dynamic cross section view. It says locate corridor or alignment and select or open view. So left click in this blank view. See. So this is your section. Let's change the view properties. Let's set the vertical acceleration to 5. And now you can clearly see your corridor. So you can either navigate through the sections like that, or you can just type in some values. So in the plan view, you will see this cyan line. It will show you at which location we are viewing the cross section. Okay, then you can create and apply the super elevation. So to do that, go to this corridor tool. So the workflow to create super elevation is create super elevation sections. And set minimum tangent length. If you want to create a single section, put in the higher value. So lane creation method set to manual. And set the super elevation. So left click to accept, locate corridor or alignment. So from here, you can select the super elevation file where all the calculation tables has been created. A selection, design speed set to 50, method is ground, and left click to accept all the parameters. See, so this is how quickly you can create the super elevation in few clicks. If you want to match the slope of this shoulder with the lane on the both of the side, you need to make some changes into the template. Okay, you set the cross fall on the slope same as of this lane, and it will match. Okay, you have dedicated tool uh, to compute the quantities. Okay, so here we have the corridor reports. So click in here and select your corridor, and it will give you all the reports of the material used. So fill volume, mass aggregate. So these represent the shape here. If you hover over the shape, okay, so this is the TC concrete pavement. So see, this is TC concrete pavement. Okay, and you can see the volume in cubic yard as we are using the metric units. So total cost of the material like that. So this is all set. If you want to create a report section wise, click on the report, and you have all the report templates you can select from. So this is the section wise. Let's see. You can format your report like the station is set to SSSS if you want to use like this. And okay, just close. And now see the station now appear as SS plus SS format. So you can save this report as XML file or a web page or Microsoft Excel. Okay, and then so our corridor model is ready. And now let's see how you can quickly create a drawing using the dedicated drawing tools. So let's create cross-section drawings. Yeah. So for that, go to drawing production, and from here we have this named boundary tool. So place named boundary. So named boundary is like placing section planes to the corridor. So while placing this named boundary, this section plane, we define the left and right offset, and the chain edges means the interval. At what interval you want to cut the sections. We can include all the cardinal points, geometry control points, and you can also create event points if you want to cut the section at any specific location. Let's say for wherever any culvert is crossing or anything, any utilities, and you want to show it in your cross section. So you can define a event list. Let's close this and quickly restart. You can just right click and open with, select your tool. Okay, so it's auto saves the drawing. So when it crashes, all your data is secure. Let's create two views this time. So remember to create cross section. One 3D views must be open. On the drawing production, again go to named boundary, place named boundary, and click on this civil cross section. Okay. So we'll use a seed file. So as you now understand the seed file, it contains all the settings. Okay, so when you select a seed file, see, it will fill all the settings which is defined in that seed file. So you don't need to do it manually. Now it says select your alignment and just hit Alt and see. So if you want to change the interval, let's say change the interval to 100, otherwise it will take more time. Okay, that's okay. And you can snap to the endpoint, or you just use Alt key to snap. Left click to accept. And the 3D view, now you can see this section has been placed. Okay, now again go to the named boundaries. And we have this cross section group, zoom baseline, right click. And create cross section sheets. Okay, so you can see here your sheet's been created in just few clicks. So it's annotated pretty well. So these are the drawing model. So these represents a 3D design model. These represents a drawing model where you put annotation to your drawing objects, and then This is the sheet model. See, this shows your super elevation. In the same way, you can create your plan and profile sheets. So this time open two views. So to create plan and profile, again, you use this named boundary tool, place named boundary. This time we need to place plan. Again, use NSID plan profile plan. So this is the seed. So we are creating plan profile sheet, and for the plan profile sheet, we are cutting the section on placing the named boundary for plan. So this is, see, it sets the your left and right offset and the length. So it says I defined the path element, means the alignment, start station and end station. Left click to accept. So the named boundary or these clip boundary for the plan has been created. Now we need to create it for profile. So place named boundary, and this time we'll be creating this profile. Pick the seed, NSID, plan profile, and this time we are placing named boundary for profile. Okay, so now this says, so method. So this time we are not setting it, placing this as per the station limit. So we are syncing it with the plan named boundary. So method is set to from plan groups. Identify profile view. And see, left click to accept. So now we have this drawing boundary created, name boundary created. So again, go to from here, and from plan groups, this geometry line. And create plan profile drawing. And you can see here. So though we have created this using the automated workflow, you can edit it manually if it is required. Let's say I need to bring this down. So just go to home on the test tool. You see, this is the plan, and here we have tool move reference, and you can move it manually. Let's see. This is how you can manually edit. Okay, so this was all about the OpenRoads designer, modeling in OpenRoad designer. So this is a quick demonstration. So let's jump onto the next software. This is OpenRail designer. So first I'll close this. Okay. So this software looks quite similar to OpenRoad Designer. All the features which we have discussed for that OpenRoad Designer will be available here, along with some dedicated tools for railway modeling. So this time we will be working in metric unit as this data set is. So in the same way, just hit new. And again, pick a seed. This time. So you won't feel any major difference while working in OpenRoads or OpenRail. So the design calculation for the alignment and other parameters may vary, but the workflow is quite similar. The user interface is very similar. So you will see everything, the workflows, the views. See everything. This is the backstage window. So if you go here, you see. So you don't see that background map option here, as I said. So here the GCS is not set. So the data set is like without the GCS. That's why until unless you don't set that geographic coordinate system, this background map won't appear here. You will have all these view controls similar, all the views you can open manually. Okay, all the tools which you have in the OpenRoads designer, except so this is an extra tool, dedicated tool for rail design. You can see it here. Okay, so let's start with importing our attaching our terrain model. So this is our terrain model. Let's add another file. Okay, so these are our the PI points. So let's start creating a geometry. Same. So workflow is similar. The tool is quite similar. So create the line between points. The feature definition may different for the rail. Okay, let's see. So we are working with rail center line proposed track 1. First tangent. Second tangent. Third tangent. Okay, next thing, tracing arc between elements. So this time we'll place a combined curve with a spiral. So let's say radius set to 1075. One, two. Change this to first element, second element. So now we have created the components. So we need to complex them. Complex by element. Again, set the feature definition. Alignment rail. Now give this a name. Main track set this to automatic. Left click to accept. So our horizontal is completed. Let's set this to active. Okay, so now let's create our vertical profile. Select, hover over, open a profile model, select a view from here, left click in the view. So this is a mountain area. So let's do our vertical. So from this vertical group, place line, profile line between points. We'll do a simple grid. Okay. Okay, so I forgot to set the feature definitions. I'll delete this. Again, I'll take this tool and set the feature definition, alignment, rail, first point. So this feature definition doesn't have to do anything with the design data. It just controls the display of your object, the color, line style, etc. So if you don't select any feature definition, it won't do anything with your design. And you can do it on later stage as well. So right click, select and set this as active file. Okay, so this is done. Now let's create turnouts for the siding. So go to rail and we have these tools. Place crossing, place turnout. So we have feature definition for the turnout geometry is created. Okay, so hand we are pressing on the right hand side this time. And this is leading. Placement by point. So locate this center line. 2 point set to 450. And zoom in and set the direction. Select orientation. First one is created. This time we'll be creating on the opposite direction. So this will be left hand side and trailing. Select the center line. Type in the chain edge. Okay. Okay, so now we need offset alignment for the center line. So in the geometry tab, we have these tools, offset and tapers. So we need a single offset partial. Don't need to create offset for the whole alignment. So we'll be using this offset and tapers, single offset partial, and the offset. So select this feature definition, set again this to rail. Proposed track 2, parameter set to 5. Start station, let's start somewhere here and end it to mirror no, and then. So now we need to join these with a curve and complete our siding geometry. So the first thing we need to extend this. So we'll place line from element, simple line from element, select this, and from the endpoint, snap to the endpoint. Set the feature definition again to trim extend, set this to none. Again, do it for this turnout, snap to the endpoint and go till here. Trim extend. All right, now we'll place the curve. So arc between elements, simple arc, first element, second element, uh, 250. And this time we need to trim both of them. Same way, 1, 2, 250, trim both. So all the components of the siding geometry has been created. We now need to complex them to a single alignment. So complex geometry, complex by element, locate first element, okay, locate and verify the direction. And left click to accept the complex. So this time, now we need to do the vertical profile for the siding alignment. So as the siding alignment needs to be at the same level of the main line alignment, we don't use this alignment tool. We just need to project the elevation from the main line to the siding geometry with zero slope. So we have this tool. So go to this profile creation. And we have this project profile to element. Select element to project. Then it says select plan element to project onto. Sorry, I used the wrong tool. So I need to use profile by slope from element. Locate first element of profile is this. Next element or reset to complete. So we have one complex element. So just right click to reset. And it says locate reference element. So my reference element is this. Parameter slope, it needs to be on the same elevation. So slope would be 0. Point selection, all points, and profile adjustment, none. Vertical offset, none. It's done. So when you open the profile of this siding, so you will see a profile line created here. All right. So next, now let's create a speed table for this mainline alignment to create Kant. So go to rail and we have this speed table, locate alignment, left click to accept. So there may be a single section with the same speed, or there can be a multiple section. Let's say we have 3 section in here. So create a new one. So parameter station, this time we'll be using 4000, accept, and speed will be 90. Again, create this time 10500, and again back to 120. So we have created this. So we can create multiple schemas. You can see here. So let's give this a name. Give this a name express. And this is freight with low speed. And for the freight, we'll be using 90, 70, and 90. Okay, so the speed table is created. Now let's create Kent, locate center line. And parameter start, alt, parameter and again, alt. Parameter speed scheme, set this to express. Equilibrium constant, set the calculated value. And parameter applied constant looks okay. Rotate about the inside rail. Feature name, Kant, and the Kant is created. So now we'll create our corridor, rail corridor. So workflow is similar to what we did in OpenRoads. Just hit new corridor. It's a locate corridor baseline. Locate profile, reset for active, right click. So feature name, yeah, main track. Okay, now it's asking for a template. So alt down, and you can select from the templates, rail. So we have single track ballasted, and hit OK. Left click to accept the selection, and then parameter start, hit alt, left click, and hit alt. Drop interval, set 25. Okay, so this is created. Let's see this in the (3D) view. So open two views, plan and 3D. You can see it here. So if you want to modify the parameter you have used while creating the corridor, let's say I've used 25 as an interval and I want these to be closer. So this is the tool for corridor object. You select the corridor and it will tell you. So this is the interval. If you want to change, let's say I want to change to 10. And now you can see the change. Let's change this to 5. See, so it's good. Between these 2 points, we have these mountains. So we cannot use simple slope. We need to design a tunnel. So we'll be placing tunnel in between here. So again, go to and locate corridor. And here, so these are the template drops. So this time I'll create a new template drop. So all down. So we need tunnels this time. So single track tunnel. Hit OK. Left click to accept and select it 4000. Left click to accept and again left click to accept. Parameter drop interval. And done. So you can see here this tunnel. Okay, so let's apply Kant. So it's very simple. Just go to rail. Kant has been created. So just assign Kant to corridor. Locate Kant, locate corridor. Select all Kant. So this is my only one section. Right click to yeah, and hit OK. So Kant has been created. So let's see in the cross section view. So let's open 3 views. Plan cross section in 3D. Okay. View properties. Change this to 5. Like that. It's good in 1:1. Okay. So let's move to see the Kant. So the Kant is created here. Okay, now let's create corridor for our siding. So for the siding section, we need a template which will create a corridor for main line as well as the siding. So again, go to corridor and from this corridor object, locate the corridor And we need one more template drop. This time we'll use single track siding, right? So this is a special template created for siding track. So it will follow a point control. Okay, and this will widen this section. So left click to accept, and we'll start from 400, accept, until 1500, accept, drop interval. Let's okay. So you can see no change here. Let's go to this section 500. So you see, so this is a point. We'll be applying a point control. Now locate corridor. Here we have a point control. We'll create a new point control. So parameter start again 400 and 1500, accept, parameter description, siding 1, left click to accept, locate point. So we'll locate it from here. So the point will be PGL branch, mode set to horizontal, linear geometry, locate planar profile element. So we'll pick our siding geometry, use as secondary, yes, priority 1, and accept these parameters, default parameters. But yeah, see. Okay, so see, the siding has been created here. So let's see our tunnel section. So it's can go directly, let's say 5,000, and you can see your tunnel section. So for now, we don't have any rail or sleeper placed. That's why it's not appearing here. So in OpenRail, you can integrate the rail and sleeper to your typical section, or you can create separately. Okay, let's see section here. Okay. And at the turn, okay, so see the cant in opposite direction. Okay, so our corridor is ready. Now let's place our rails and sleepers. So we have dedicated tools here to place rail and sleeper. Within the rail tab, we have this rails, create rails and create sleepers. So just click create rails and set the parameters. Select the single rail. Locate the center line. Start station. End station. So in the 3D, you can see the rails been placed here. You can see it in your cross section. So within the tunnel also you have this. Okay, now let's place it for our siding. So you simply need to locate the center line. Okay. So let's look at this section. Go to 1000. And here you have the rails placed for main line as well as the siding. So now let's place sleeper. So from the same tool group, select create sleepers and you set the parameters, the sleeper length, width, etc., vertical offset like that, and select the rails created. So this is my rail mesh. So start, hit alt, or end, hit alt, left click to accept. Okay, so sleepers been created. See, if you change the view perspective, let's say transparent, default, you can see it very clearly. Okay. Same way you can create it for the siding. Select existing rail flag, alt, alt, and then. So let's see in the cross section. See. Okay, so our corridor is completed. We have the similar tool. For the corridor reports, similarly select a corridor and it will give you the component quantities. Let's see. The cutting, filling, and etc. So it calculates for the shape available within your template. So this is one shape, this is one shape, this is one shape, like that. You can create report. See, again, you can change the format from here. You can save this as Excel file or Word file. Okay. So we have the similar tool for the drawing production here. The drawing production, you will see the same named boundary tool in here. Place named boundary. Civil cross section, A1 cross section. Let's see. Take this create drawing. Now it says select your mainline alignment. Alt. Interval again, set this to 100. That's okay. Left click to accept. So you can see these section planes placed in here. And again, this is a create drawing window appears. And verify the settings. This comes from the named boundary and hit OK. So this is a long stretch. That's why it's taking time. Okay, you can see the section. Let's go to 10 plus. Yes, yeah. So this is the Kent section. Let's go to the tunnel section. So this is about 4, 5 somewhere. Yes. Oh, what happened? Okay. So as I said, we can adjust these manually. Okay, so these are the drawing. Okay, now let's create a plan and profile drawing. So let's open two views. And create named boundaries. So select the seed, A1 plan, profile plan, 500. Identify the alignment. Start station. Set the end station. And accept the named boundaries. Just cancel. And again, place named boundary for profile. Set the seed to A1 plan profile. Station limit method set to from plan group. And click in the view. So it says the boundary will not fit because the height is so, you need to make changes to the seed file. So let's say change our alignment this time. We'll create for the sort section. So this time again, place named boundary, plan, plan profile plan. And this time let's select your center line as accept, cancel. Place named boundary, profile, plan profile. Before that, I need to open profile view for this. So we have this profile in view 3. Let's no. Let's hide this. Go to corridor, attach tool, and we have this 3D model attached. So I'll just hit. Okay, so now I can hover over this and open the profile. Okay, we have this profile now. So go to drawing production again, named boundary, place named boundary. It's already set. So select your profile and set the method from plan group. Okay. Yes, this time. This time. So from the plan group, let's first delete main track. So we have this only. From plan group. Okay. So it was picking the plan group for this main line. That's why it was creating the lots of name boundaries. Now it's okay. Let's left click to accept. And yeah, we have this tool to create drawing. Hit OK. All right. See, it's been created. Second sheet. Yes. All right. So this is all from my side. Thank you very much.